we are going to talk about rest and motion. And so we take an example of a car on a street and a person standing, a bystanding person. So the car is moving, and the person observes that the car moves towards this side. And we see I have not drawn anything else, no tree, no other person, no other vehicle, just this person on the side and the car in the middle of the street moving towards the right direction. This person observes, this person is stationary, and this person observes that the car is moving towards the right. We are seeing as this person. Now we get inside the car, and when we observe this person on the road, we observe that this person moves towards the left. I hope you get what I'm saying. When this person stands as a bystander, he observes that the car moves towards the right, and this person observes that this person is moving towards the left. And this simple example shows that it is a matter of from where you watch, from where you observe. The motion or rest of the person depends on your frame of reference. The frame of reference, from where you observe. This is your frame of reference is from this person. You observe that this person moves towards the right. If your frame of reference is this person, this person is your reference point, and the car moves this side. In actuality, that the car actually is moving this side, but we see what is apparent, what the person in the car observes. He observes that this person is moving towards the left, and that happens a lot of times, and this is a very ideal situation, because I have not drawn any other reference, what we consider as references. If there was a tree here, it is common sense, not common sense, everyone knows that the tree doesn't move. Obviously the tree doesn't move. And now when the car passes from this point, the driver observes the tree, and he will observe again that the tree moves towards the left. Everyone knows that the tree doesn't move, but the observation will be apparent that the tree moves towards the left. But now, as from knowledge, when you see we grow up, we know a lot of things without people telling us that the tree doesn't move. And now as the car actually goes past this and sees the tree moving towards the left, it's very obvious to him that the tree is not moving towards the left, and the car is actually moving towards the right. But we have not taken any such reference, no previous knowledge or no such reference. It's just this person and this person in the car, and we see that it depends on the frame of reference, what you have chosen as the frame of reference. We have in actuality put this person stationary and this is moving, but they both observe each other to be moving and themselves to be stationary. When the car is the frame of reference, we don't see the car to be moving. It seems to us that the car is stationary and everything else is moving. That is what is observed, but we know that that is not so, but that is what is observed, and we are talking only about observations when we are talking about rest and motion. Nothing is in absolute rest or motion until we determine the frame of reference. Rest and motion have no meaning without an observer. There has to be an observer to determine rest or motion, and it can go either way from either observer, like just the way we see now, the way we have seen now. And now if we add a clock to it, we see this moving with respect to time. If there's a clock, the clock no one stops the clock keeps ticking, and this car keeps moving, right? We say, now we also put a time to it, and we say that the position of the car is changing with time, so the more and more things we add, the more better descriptions we have. Another example we take for rest and motion. There's a train. If there's a train and everyone is sitting in the train, let's say everyone is sitting in the train. Everyone is sitting in the train. This is the window, and there are many windows, and this is the whole train, and these are the tracks. So now this train is moving. We know the train is moving, and again, let's say now that the frame of reference is the rail track. And from the rail track we see that the passengers are also moving towards the right, because the train moves towards the right. They are inside the train, they are attached to the train, so they are moving towards the right. Okay, from the frame of reference of the rail track, now we consider yourself to be inside this train, and when you are inside this train, you will see that the passengers are at rest, the train is also at rest, and the railway tracks are moving this side. Do you get what I mean? From here we see that the passengers are moving, the train is moving. From here we see that the passengers are at rest, the train is at rest, and the railway tracks are moving towards the left. So we see that this is a matter of frame of reference. Rest or motion is a matter of frame of reference. It all depends on from where you watch, from where you observe, and the easiest way to determine the position or the change in position. If there is a change in position, there has been motion. There cannot be change in position without motion. So if we say, so the easiest way to say that there has been a change of motion, there has been a change of position, therefore a change of motion, is to determine this. Then we have to find a way to determine the position, and the easiest way to do that is to have three mutually perpendicular axes, x axis, y, z. We can put whichever anyway, but when we do that, we should stick to it, or we get all confused and get all the wrong answers. And then we have determined this. Now this is 0, 0, 0. The point, this point is 0, 0, 0. Now think that these people are at 0, 0, 0. This is the y-axis. Now these people move here till here. Now the y coordinate has changed. Let this be x, y, and z, just for the sake of saying. And they have come to here, and let this be 1 unit. The y coordinate has changed, so the x and z has remained the same. The train hasn't moved this side, or it has not gone up, it has only moved this side. So now the new coordinate is 0, 1, 0, just to say. And now we know that as it has moved from 0, 0, 0 to 0, 1, 0, there has been a change of position, and as there has been a change of position, there has been motion. So there has been motion, and if we add clock to it, we can also say that there has been a change, this change of motion took place in this much time. If this took place in 2 seconds, if this took place in 2 seconds, we can say that this position changed to this position in 2 seconds. Thank you. This was about rest and motion.